the first thing would be to look at a sketch of the graph, and it looks pretty crazy. Something like that. We need to figure out this area. Not just the top area there. I feel like some people might have gotten confused with that. Yeah? So the first step is to sketch the graph. The second step is to figure out what area you're looking at. And then the third step is to figure out the bounds. Like, if I'm gonna, like the left side of it is x equals 0. That's easy to see just because it gave us the y-axis as one of our boundaries. The other boundary is when x is that. And that is where the x squared minus 6 and 6 minus x cubed, that's where they cross. And what I usually do is I look at the graph and I guess something, if I can, or I set the two functions equal to each other. Yeah? So here, let's see what happens. I want to find this point. I already know that this would be x equals 0. So I have 6 minus x cubed equals x squared minus 6. I suppose I could get everything to one side. X cubed. This is not going to be nice. Is it? Is it like 2? 2 something? Well, let's see. I'll move the x cubed over. I will subtract the 6 over. So I have plus x squared minus. Yes, this is like a weird function to solve. To do it by hand, we would try synthetic division. And I was thinking synthetic division is only going to help if I have like nice numbers or nice fractions. So then I zoomed in and I was like, is it close to a nice number? And I zoomed in and it looks like it's 2. So I'm going to guess 2. If I plug in 2, does it work? 2 cubed is 8 plus 4 minus 12. Yep. So the steps, once again, are. So I should write this down. X equals 2. So I should first graph everything. Second, figure out the region that they're talking about, shade it in. Third was to find the limits of integration, basically, the left bound and the right bound. Sometimes we'll integrate with respect to y, so we'll be going up and down. But in this case, we have just x values. And then use the graph, if you have a complicated situation, use the graph to guess and check to see where they intersect. What's that? So I know that I'm going to have the integral, and the idea for area between two curves is you integrate over some region, and you have the top function minus the bottom function. So in this case, the top function would be 6 minus x cubed. The bottom function would be x squared minus 6. And I'm integrating from 0 to 2. The top function, we just said, was 6 minus x cubed minus, right? Yeah. X squared minus 6. Bless you.
Bless you. Thank you.
I think maybe if you want to write this down, you would have the integral from a to b, top minus bottom, dx, I suppose. Top function minus the bottom function, because that captures the area underneath. I mean, between the two. So if I had two curves, and they were like this, and I went from A to B, the area underneath the red one would be that. If I want the area between the two, then I could figure out the area underneath the blue one and then just subtract that away from the red area. Do we understand that? That's why we're subtracting. And then it just generalizes to functions that are underneath. Because if you subtract a negative, you're actually adding more area. So it never actually gets negative area when you're doing between two curves. So let's do this integral. So I'm just simplifying it as much as I can, then I'll just take the antiderivative and evaluate. So this would become 12x minus x to the fourth over 4 minus x to the third over 3, evaluated from 0 to 2. So I'll plug in a 2, and I get 24, minus 2 to the fourth. What is that, 16? 16 divided by 4 is 4. 8 divided by 3. And minus 0, right? Because when I plug in the 0, all of those go away. So 20 minus 8 over 3. Whatever that is, I don't want to get a common denominator. So we have the same instructions. Sketch the graph, or sketch the region bounded by these functions. What's that? Correct. Sketch the region bounded by these, and then calculate the area for that region. Here is your hint that you should be integrating with respect to... Actually, you tell me why. Like, in this one, you integrate with respect to y, but everything's isn't in terms of y anyway. So that's, I guess, not you tell me, but I'll tell you again. That's your hint that you should probably integrate with respect to y. Everything's already in terms of y. If it's in terms of both x and y, like neither are solved for, you can choose. You just solve for one of them and go. This one is kind of weird to graph, right? I feel like that's the weird part. So what I do to just for getting the graph, and then I ignore the other